Good evening, friends. Today we shall study about the jet stream, which is a important factor for our monsoonal season or monsoon of India. So that we have to study the jet stream vividly to discuss upon the monsoon. Now, a different pattern of air circulation is observed as a height of about 3 km above the surface. As I have drawn in the map in red ink, showing that the jet stream is flowing from west to east direction. The arrow is showing that west to east direction. It is a different pattern of air circulation which can be shown not in the surface level here, not in the surface level, but above the high level of tropospheric layer. Okay, so to understand this jet stream, we have to follow the class vividly. It is said that the jet stream is a different pattern of air circulation. First and foremost point, it is a different pattern of air circulation circulating from west to east. Okay, it is observed in a height of about 3 km above the surface. It is observed in a height of about 3 kilometers above the surface, 3 and plus 3 or above the 3 kilometer. It normally shown in height of about 9 to 13 kilometer. The jet stream is normally shown in about 9 to 13 kilometer in the atmosphere. The direction and velocity of winds and the height, are different from those of the surface wind. Now, this is a differential kind of wind, which is direction is another, velocity is another, and height is another. It is not flowing in the surface level. It is flowing above 9 to 13 kilometer level in the atmosphere, or mainly in upper troposphere of the atmospheric level. All of Western and Central Asia remains under the influence of westerly wind along the altitude of 9 to 13 kilometer, and it flows west to east. Western and Central Asia, not only in India, it is Central Asia and Western Asia. This area too, the jet stream is found to flow in the height or altitude of 9 to 13 kilometer, and the direction, as I said earlier, that west to east. These winds blow across the Asian continent at latitude north of the Himalayan, roughly parallel to the Tibetan highlands. This is a wind flow which mainly seen in Tibetan highland. Where is Tibetan highland? This is Tibetan highland. I have drawn here the jet stream. This one is jet stream in northwest India. So it is found that the jet stream is flowing in this direction, parallel to the Himalayan range and the Tibetan plateau, parallel to the Himalayan range and Tibetan plateau, in the height of 9 to 13 kilometer, in a direction from west to east, as shown in red ink in board. Tibetan highlands act as a barrier in the path of this jet stream. So, in case of this jet stream, the Tibetan highland and the Himalayan range also, its role is as a barrier or obstruction in the path of jet stream. And jet stream originally found in a height of, as I said earlier, 9 to 13 kilometer. As the Tibetan highland and Himalaya is a barrier in the path of jet stream, resultantly jet stream gets bifurcate. The jet stream gets bifurcate. This jet stream getting obstruction in Tibetan plateau and Himalayan range, it gets bifurcate and goes towards north, and a branch goes towards south. But remember it, this jet stream flows in the upper level of the sky or the upper level of the atmosphere, which level generally 9 to 13 kilometer level of atmosphere. And generally this jet stream can be seen in a latitudinal position of 25 degree north. It is bounded between 25 degree north, where it is 23.5 degree, and this one is 25 degree north. The jet stream is generally found in 25 degree north. It is responsible for bringing western disturbance. As you have studied in earlier classes, that western disturbance is coming from Mediterranean Sea in winter season in India, and the western part, northwestern part of Punjab and Himachal Pradesh. Come here, the western part of Punjab, Haryana, Himachal Pradesh and Uttarakhand. Himachal Pradesh, Uttarakhand, Punjab and Haryana, and some western part of Uttar Pradesh. This area gets a rainfall in winter, which helps to product the wheat production, or helps to cultivate the wheat here. So, as I said, the western disturbance coming from Mediterranean Sea, the jet stream is attracting the western disturbance towards this direction. So, as you seeing that the jet stream is flowing in the northwestern part of India, it is attracting the western disturbance from Mediterranean Sea to enter into the Indian subcontinent and helps to rainfall at Punjab, Haryana, Uttarakhand and Himachal Pradesh and Uttar Pradesh western part, and to grow the wheat. This is important to discuss about the western disturbance in India. Okay. So, according to western disturbance in India, in winter season, it comes in winter season, and it winter rain and hailstorms in northwestern part, and occasionally heavy snowfall is in hilly areas are caused by this disturbance. So, in the northwestern part of the India, the western disturbance helps to rainfall for some days, and some storms, hilly storms and snowfall in hilly areas of Himachal Pradesh and Uttarakhand. Okay. So, this is the mechanism of western disturbance. Now, have a short discussion again upon this phenomena, that the western disturbance is a resulting or cause and effect of jet stream. So, now come to jet stream. What is jet stream? It is a air flow or air turbulence flow in upper height or upper altitude of the atmosphere, generally in above, in and above 3 kilometer from the surface, in and above 3 kilometer from the surface, but the map showing that the 80, 60, 40, 20 kilometers lines, and we have drawn the jet stream line. Okay, the jet stream is coming from west to east direction in parallel to the Himalayan region and Tibetan plateau. So jet stream is coming from west to east direction parallel to the Himalayan region, Himalayan mountain and the Tibetan plateau. This is the direction, and here is Tibetan plateau and the Himalaya are resisting or obstructing the jet stream, and therefore the jet stream bifurcated into two parts. One goes to northward and one goes to southward. Okay, this is the mechanism of the jet stream. Now, jet stream attracts the western disturbance which is coming from Mediterranean Sea and entering to the Indian peninsula as for the attraction of the jet stream. And it is the western disturbance is not a high altitude air turbulence, it is a surface air flow. It is surface air flow. Okay, and we can see that it comes generally in winter because of jet stream attraction, and helps to rainfall over these states, that Punjab, Haryana, Himachal and Uttar Pradesh, and some area is snowfall. That's why these states are the wheat cultivation land. This is the mechanism of jet stream. Now, tropical cyclone originate over the Bay of Bengal and over the Indian Ocean. Okay. The tropical cyclone have very high wind velocity. Tropical cyclone have very high wind velocity and heavy rainfall, and hit these areas where Tamil Nadu coast, Andhra coast and the Odisha coast. So, tropical cyclone are very destructive due to high wind velocity and torrential rain accompanies with it. So, this is the tropical cyclonic area which originates in Bay of Bengal and Indian Ocean, and resultant rainfall and storms are seen here mainly. Now, weather condition in summer region, we have to see the weather condition in summer region to understand the coming of the monsoon or the mechanism of the monsoon. As the summer sets in and the sun shifts northward. Why summer comes in northern hemisphere? Because the sun comes toward the northward. Now comes on and upon extremely upon 23.5 degree latitude, and it shines directly upon the Tropic of Cancer. This is the summer season in northern hemisphere. Okay, so as the sun shifts from equatorial region to tropical region, resultantly wind circulation over the subcontinent undergoes in a reversal path or undergoes complete reverse. The wind circulation of on and over the Indian subcontinent undergoes complete reversal at both the lower as well as upper level. As I said, the jet stream in upper level and the surface stream in lower level. In the middle of July, what we can see? We can see that intertropical convergence zone shifting northward. As the sun is shifting northward, that's why the ITCZ of 0 degree or equatorial region shifting northward, roughly parallel to the Himalayas between 20 degree north and 25 degree north. Here it is 20 degree north and it is 25 degree north. The ITCZ exists here, this location. Okay? In the summer of northern hemisphere, the ITCZ exists upon the globe, not only in India, upon the globe in 20 degree north to 25 degree north latitude. In India, it extends from Punjab to the Chotanagpur Plateau. In India, the ITCZ surface wind extends from Punjab to Chotanagpur Plateau, and this area called as low pressure cell. In summer, this area undergoes of low pressure cell. The westerly jet stream withdraws from Indian region. As you studied the jet stream in winter coming from westward, it completely withdraws and exits from Indian peninsula. Okay, so now here it is ITCZ and jet stream completely exited from northern from Indian peninsula. So there is a cause and effect relationship between the northward shift of ITCZ and the withdrawal of the westerly jet. This is vice versa. As the ITCZ shifts northward, it pushes the jet stream to exit from the Indian peninsula. It is a cause and effect scenario, or it is the cause and effect relationship with ITCZ and the jet stream. Here you can see that there is a relationship between the jet stream and the ITCZ. Okay, either the jet stream comes and pushes the either the jet stream comes and attracts the ITCZ, or the ITCZ comes northward and it pushes out the jet stream two-way out from India. Now, as I said earlier, this is a low pressure cell or low pressure belt from Punjab to Chotanagpur. The ITCZ attracts wind from all round. Here the low pressure attracts winds from all round. This area, this and this and this also. Okay. So the wind has been attracted from all round. The maritime from the southern hemisphere, the main wind comes from the maritime or the southern hemisphere. In southern hemisphere the direction is southeast, and as it crosses the equatorial belt or equatorial line, it gets in different direction, that is southwest, and the southwest wind is coming to enter into Indian subcontinent in attraction of the ITCZ or the low pressure cell in northern India. As the southwestern wind comes from the Bay of Bengal, Arabian Sea and the Indian Ocean, so it collects additional water vapor from the water bodies. It collects additional water vapor or moisture from in its own, and which is popularly known as the southwest monsoon. By collecting additional water vapor or moisture, the southwest wind enters into India. Why it enters into India? Due to the ITCZ drifting or shifting of ITCZ in northern India or 20 to 25 degree longitude, and origination or creation of a low pressure cell or low pressure area or low pressure zone in the northern India, the southwestern monsoon or southwestern monsoonal winds, rather it is the southeast trade wind converted into southwestern monsoonal wind, enters into India. While entering, the wind get obstruction from the Western Ghat or the Sahyadri hill, and it sets rain in the western side of this hill, and after that it enters upon the mainland. The mechanism I shall discuss it in a complete class. Now see the position of ITCZ. Initially ITCZ is existing in winter on 0 degree or the equator, on and upon the equator or the 0 degree latitude. But as summer comes, the sun drifts from south to north. The ITCZ also drifts from northward, and in July, in summer, in northern hemisphere, the ITCZ exists upon 20 to 25 degree latitude. So, the drifting of ITCZ is very important to come monsoonal wind in India. To discuss the Indian climate, it is very important to understand the drifting of ITCZ. Why the ITCZ drifting in northward in summer? Because the sun is drifting from northward in summer. Okay. So this is the figure shown the drifting of ITCZ from south to north. Now see the position of ITCZ. Initially ITCZ is existing in winter on 0 degree or the equator, on and upon the equator or the 0 degree latitude. But as summer comes, the sun drifts from south to north. The ITCZ also drifts from northward, and in July, in summer, in northern hemisphere, the ITCZ exists upon 20 to 25 degree latitude. So, the drifting of ITCZ is very important to come monsoonal wind in India. To discuss the Indian climate, it is very important to understand the drifting of ITCZ. Why the ITCZ drifting in northward in summer? Because the sun is drifting from northward in summer. Okay. So this is the figure shown the drifting of ITCZ from south to north.